In the last video, we wrote an equation with two unknowns to represent Ben and Dorothy's age. In this video, we'll talk about why is it a linear equation. To do that, we're going to have to reflect on some prior knowledge, okay? So, over here, I have number lines. Okay? Right there. Now, over here on the left, I have maybe expressions you've seen before, okay? If I wanted to plot this on the number line, how would I plot x equals 3? Well, notice that this is my x, it's an x number line. That means it's representing all the values of x that would make this equation true. Well, what values of x would make this equation true? We would say only 3. 3 would be the only answer to this equation. So what I would do here in order to graph this is I would put just a dot over 3. And this dot represents, it represents the solution to this equation. Now let's go maybe to x is greater than 3, okay? What would be a solution, or what number could I put for x that would make it true? Well, 4 would work, 5 would work, 5.5 would work, 5.75 would work, and so forth. Any number that's bigger than 3 would work. So how would you graph this? Well, at 3, is 3 bigger than 3? No, 3 is not bigger than 3, so I can't include 3. So I'm just going to leave this open. This is an open dot because I don't want to include 3. And it's anything bigger than 3. So that means that 4 would work, 5 would work, and really 3.3 would work, 3.5 would work. And if you kind of put a whole bunch of dots here, any of these points that are after 3 would work. And if you realize that you keep plotting all these small points, soon enough, you'll have a line. And it goes to numbers that are bigger than 3. And so here's how you would plot all the solutions to this inequality. It's called an inequality, right? Anything that's greater than 3 would work, and that would work on this number line. Now, maybe you've seen this in 6th grade or 7th grade. You have this equation. Now, this equation, you look at x, and you have to think, what would make this value, what would make this equation true? What do you add 2 to get 3? And you would say, oh, it has to be 1. So x equals 1. Now, how would I plot this on our number line? Well, go to 1, and I just fill in a dot. And this dot represents that x can only be 1. Now, we're in 8th grade now, and we're talking about, notice how these equations before that we've seen, what do they have? Notice that they only have one variable, the variable x. The equation that we're looking at has two variables. It has x, yes, but it also has y. So the question that we're after is, what could be x and y be? What would make this equation true? Well, what if x was 1? Then, that's what that sign there means, then y equals 1 plus 3. What would y equal then? Well, y would equal 4. So a solution to this would be x is 1, y is 4. And this is a coordinate point. We have an x and a y. What if x was 2? What would y be then? Well, we have y equals 2 plus 3. What would y be then? Y would be 5. So I have 2, 5. What if x was 2 1/2? Well, let's check. Y equals 2.5 plus 3. What's 2.5 plus 3? Well, y would equal 5.5. So the solution would be 2 and 1/2, comma 5. You can see we can keep going on and on to find our solutions to this equation. And you could just continue plugging in numbers for x, and your y would change just as your x would change. But how would you plot these on a graph? How would you plot them? Well, notice how before, you have to excuse me, I want to move this. All right, we'll just work with this here. All right, notice how before we just had x values to worry about, right? So when x was, right, up here, we just had x is equal to 1. So all I had to worry about was plotting my x-axis. But here I have y values I need to worry about. So how do I plot my solutions to this equation? Well, we don't just need an x-axis, we also need a y-axis. Okay? Here's our y-axis. And just like our x-axis, our y-axis will have numbers on it. Some of you probably have seen this before. And I'm going to put 1, 2, 3, 4, 5, 6. Sorry about the space here. So the question here is, how do I represent the solutions, all the solutions to this equation? Well, when x is 1, which is right here, my y is 4. So if I plotted x equals 1, that wouldn't make sense, because that means that x is just 1. But if I'm looking at my y-axis, y would be 0. So in order to graph 1, 4, I would go up to 1 on my x-axis and 4 on my y-axis, and I would meet in the middle there. I do the same thing with 2, 5. Okay? And 2.5, 5.5. I wonder what x would be if it were 0. So if x is 0, what would y be? Y would be, well, what's 0 plus 3? Well, that's 3. So when x is 0, y is 3. And if you can kind of notice this, you see that these solutions that we plotted, they kind of form a what? A line. In fact, if you were to find all the solutions to this equation, you would find that they make basically all these small solutions would make up the line. Every point on the line, all the solutions, really the line is just made up of points, and the points are just solutions to this equation. So the reason that this is called a linear equation is because when you graph all of the solutions, your solutions will form a line on the graph. And we'll explore this later in chapter 4, but I wanted to just make sure you understood why is it called a linear